Did you know? When the US website Sony reported with near astonishment that China's second J-36 prototype had undergone major technical upgrades within just 10 months, global military observers suddenly realized that the pace of modern fighter jet development was being redefined by China's aviation industry. This represents more than just an improvement to a new fighter jet. It is a concentrated demonstration of the maturity of a nation's aviation industrial system. From the debut of the first prototype to the emergence of the second, fully optimized prototype, less than a year has passed. This iteration speed far exceeds traditional aviation R&D cycles, reflecting revolutionary breakthroughs in China's aviation R&D methodology. A close examination of the visual changes between these two J-36 variants offers insights into the technical thinking of Chinese aerospace engineers. The most striking transformation lies in the engine nozzle design, carrying profound implications. The initial model adopted a concealed nozzle layout reminiscent of the YF-23, prioritizing all-around stealth performance. The new variant, however, boldly switches to an exposed, serrated dual-vector nozzle. This adjustment grants the J-36 direct thrust vectoring capability, mirroring the J-50, significantly enhancing subsonic post-stall maneuverability and high-speed maneuver recovery. More intriguingly, this design choice reflects Chinese engineers' profound understanding of tailless fighter configurations. Using thrust vectoring to provide direct pitch control effectively compensates for the inherent stability and maneuverability shortcomings of tailless designs. In balancing stealth and maneuverability, the dual-vector nozzles may slightly increase rearward radar cross-section, but successfully resolve the low-speed control challenges long faced by traditional stealth platforms like the B-2 and F-117. This demonstrates the maturity and confidence in China's sixth-generation fighter design philosophy. Changes in the air intake also demonstrate China's accumulated aviation technology. The full transition from Garrett-style intakes to DSI design not only eliminates the strong scattering caused by the opening between traditional intakes in the airframe, enhancing frontal stealth performance, but also reduces structural weight and improves reliability by eliminating complex boundary layer separation systems. China has already applied and mastered DSI technology on multiple fighters including the J-20, FC-31, and J-10B. This latest refinement further indicates that the J-36 team places greater emphasis on minimizing the stealth signature of the frontal section, aligning with the design philosophy of head-on engagement in conventional air combat. This consistent technological approach reflects that China's aviation industry has established its own unique technical roadmap, rather than simply following Western traditions. The rear landing gear modification demonstrates meticulous optimization of internal space, shifting from a single vertical wheel to a dual horizontal wheel arrangement. This seemingly minor change effectively reduces the landing gear's longitudinal footprint within the fuselage, freeing up more flexible space for internal fuel layout and weapons bay design. Combined with the J-36's noticeably widened fuselage, it's reasonable to infer this fighter will feature larger internal weapons bays, potentially reserving space for future large air-to-air missiles or even air-to-ground weapons. This design philosophy aligns with the weapons bay flexibility emphasized in the U.S. military's sixth-generation fighter concept, indirectly confirming the J-36's pursuit as a heavy fighter of ultra-long range and formidable weapons carrying capacity. Turning our gaze across the ocean, the U.S. sixth-generation fighter program, the F-47, presents a different picture. Although President Trump announced in March that Boeing had won the F-47 contract, no physical photos have been released to the public to date. More concerning is that the project underwent a strategic pause in May 2024 due to insurmountable technical hurdles within limited budgets. The ongoing struggles of the F-35 program, including major delays in the Block 4 upgrade, soaring costs, and the embarrassing fact that only one-third of the UK's F-35 fleet is fully operational, reflect the structural challenges facing the US military aviation industry. The American aerospace industry, once the creator of the Senior 71 Blackbird reconnaissance aircraft and the B-2 stealth bomber, now appears hamstrung by bureaucracy, supply chain disruptions, and talent drain, struggling to recapture the innovative dynamism of the Cold War era. In contrast, the rapid iteration of the J-36 is by no means coincidental. It represents the inevitable outcome of decades of technological accumulation within China's aviation industry. From its initial phase of introducing and reverse engineering foreign designs to today's era of independent innovation, China's aviation sector has established a comprehensive R&D system. Chengdu Aircraft Industry Group's ability to implement such significant improvements, based on the test flight data from the first prototype, demonstrates the efficiency and pragmatism of its test fly and optimize simultaneously R&D model. This agile development process, combined with support across the entire industrial chain, including sensors, stealth materials, and artificial intelligence, has enabled China to take solid strides toward defining the standards for sixth-generation fighters. Notably, China appears to be pursuing a dual-track strategy for sixth-generation fighter development. The J-50, sometimes termed the Shenyang sixth generation, and J-36 from the north follow distinct technical paths. The former likely prioritizes full-spectrum stealth and supersonic cruise capability, while the J-36 seems to seek a systematic rebalancing between stealth, maneuverability, aerodynamics, and operational reliability. This strategy of parallel validation and selective advancement reduces technical risks while accelerating R&D, demonstrating China's strategic acumen in military aviation. From a broader perspective, the J-36's rapid evolution represents a comprehensive leap forward for China's defense industry. The comprehensive application of modern R&D methods, including digital engineering, virtual simulation, and additive manufacturing, enables Chinese aerospace engineers to complete most debugging and optimization in virtual environments, significantly shortening physical validation cycles. Concurrently, China's maturity in critical subsystems, such as composite materials, active phased array radars, and avionics systems, provides a robust technological foundation for the J-36's rapid iteration. Of course, we must clearly recognize that this new J-36 prototype is likely not yet in its final production configuration. It will still need to undergo rigorous flight testing to resolve a series of complex engineering challenges, including nozzle thermal management, the impact of wake turbulence on aerodynamic control surfaces, and the integration of the engine with overall thermal systems. Although China's aviation engine sector has made significant strides, it still lags behind the world's leading standards. This gap remains a critical factor in whether the J-36 can ultimately achieve its full design performance. Nevertheless, the emergence of the second prototype sends an unmistakable message. China's sixth-generation fighter development is no theoretical exercise. It is rapidly transitioning from blueprints to the skies of reality. At this pivotal moment of global air power realignment, the J-36's demonstrated pace of technological iteration and system integration capabilities have made the world acutely aware that the competitive landscape for next-generation air superiority is undergoing a fundamental transformation. The suspense surrounding which nation will claim the world's first formally mass-produced sixth-generation stealth fighter is diminishing. Through the J-36's rapid evolution, China's aviation industry has delivered a compelling answer.